Hey guys, it's me, Mrs. McEwen. How you doing? Getting ready to get started? All right, we're going to do add like fractions. We're going to be through this very, very quickly. This is a very easy lesson. So be prepared to be done fast. If we were in school, I would have done 2 lessons today. I would have blown through 2 and tried to double up on this chapter. Okay, here we go. Essential question. How can I use operations to model real-world fractions? Here's our problem of the day. Carl says that 293,028 is greater than 293,205 because 8 is greater than 5. Is Carl correct? I'm going to underline what he means. Because 8 is greater than 5. Is Carl correct? How does a place value chart support your answer? So I'm going to give you about a minute to work on that. All right. So, is he right? No, he's not correct. Because the 2 here in the 200 place is greater than the 0 in the 100 in the hundreds place. So a place value chart would tell us that right. Well, it's because 8 is greater than 5. We would see that this number is greater because the 2 is worth more in the hundreds place. And as you go to the left, the numbers are worth more. As you go to the right, the numbers are worth less. All right, and then let me Dun, 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 dun. Okay, there's the answer. All right, quick check. Oh, you know how we go. I usually take these slides out, but I didn't get a chance to do that, which is fine. Let's do it because, we have the time. Write a next mixed number and an improper fraction for each model. So we have 2 and 3/4. And we also can count it and say 1, 2, we have 4, 8, 9, 10, 11 over 4, right? Or 2 times 4 is 8. 8 plus 3 is 11. Now, number 2 is we have, let's see, 2 1/3 or 7/3. Okay. All right, I'm going to flip through these. I always do that when we're in class. All right. What happens to the numerator and denominator when adding fractions? So we know that what happens to the numerator is the numerator changes. So it does either the addition or subtraction. Okay? So the numerator is the one that changes. The denominator, we're learning, stays the same. The denominator stays the same. Okay? The denominator never changes when you're adding or subtracting. It never, ever changes. I still think about that one that I did wrong a couple lessons ago. And I was like, I added the thirds when I shouldn't have. So clearly I'm not getting over that. So that's That's the thing about denominators. They don't change. The thirds, it still was cut into thirds. You can't add it up and find sixth. Just like with a 3/5, if you add 3/5, it becomes 6/5, not 6/10. Okay, you never add your denominators. Never, ever, ever add your denominators. Okay, draw lines to connect each addition expression to its correct sum in simplest form. All right, so let's do that. I have a feeling I'm going to regret this in a minute. Okay, 3/10 plus 2/10 would be 5/10. Yep, I knew I was going to do that. So 5/10 would be equal to 1/2. So they did it in simplest form. 4/8 plus 2/8 is 6/8, which is equal to 3/4. 2/5 plus 1/5 is 3/5. 5/12 plus 5/12 is 10/12, which is 5/6. And 1/3 plus 1/3 is 2/3. And it's not going to let me do that, but it's 2/3. All right, let's look at the nice version. There you go. It still looks a little wacky, but there's our answers. Okay. All right. All right. You know what? Let's do it. Greta eats 2/12 bag of trail mix. Haley eats 3/12 of a bag of trail mix. Jason eats 5/12 of a bag of trail mix. What fraction of the trail mix do they get all together? Here's how I would solve it. 2/12 plus 3/12 plus 5/12. You guys, you're all going to be like, why is this so easy? 2 plus 3 is 5. 5 plus 5 is 10. So they will eat 10/12. Now, you can put that in simplest form, which would give you 5/6. Now, the only reason that the denominator changes is because what I did here, when I did it in simplest form, is I divided by the same number. It's an equivalent fraction. It's different because the numbers are different, but it's still equivalent. It's still equal to 10/12 if I divide by 2 on both sides, which would give me 10 divided by 2 is 5, 12 divided by 2 is 6. So it could be 10/12 or 5/6. So that's why you have to think back to chapter 8. Why did we do all that, multiplying by the same number, dividing by the same number? Because what the point was to tell you that when you divide or you multiply by the same number, it is equal. It's the same. It's just different numbers. I implore you to go cut up a candy bar today and find that out. Cut it into 12 slices. First 6, then 12. Never mind. Your parents will say, what is she talking about? Is she losing her mind over there at home? All right, math in my world. So, boys and girls, this is in your book, so follow along with me. If anyone can hear, Eloise is playing her accordion in the other room. All right, Pablo spent 2/6 of an hour on a jigsaw puzzle. Conrad spent 1/6 of an hour on the puzzle. How much time did they spend working on the puzzle in all? Okay, so they just want us to add it up. 2/6 plus 1/6. Remember, the denominator doesn't change. It stays the same. 2 plus 1 is 3, and then that's it. And the answer is 3/6. I mean, it can't really get much easier than that. 2 plus 1 is 3. You keep your denominator the same. End of story. How much time? So then what they did was they did this. They got 3/6. But they said, you know what? We need that to be in simplest form. So they divided by 3 on both sides. And I know that 3 is half of 6, so I know that it's equal to 1/2. 3 divided by 3 is 1. 6 divided by 3 is 2. So basically, if I did my inverse, 1 times 3 is 3. 2 times 3 is 6. So they spent 1/2. So they spent a half an hour on the puzzle. Now, the reason why they're saying that is because you would never come up and I would say, oh, how much time did you guys spend working on the puzzle? And you go, oh, we spent 3/6 of an hour. I'd say, what? No, you spent half an hour. Okay. So that's why they did it that way. Because you would never say 3/6. You would only say half. Real world. That's what they're trying to get to, is that this is a real world problem. Okay. Math in my world. Here's the next one. 3/10 plus 5/10. So 3 plus 5 is 8. And we get 8/10. But then they want you to write it in simplest form. So you have to divide by the same number on the top that you do on the bottom. Divide, 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 divide. Simplest form is when you divide. So that's why right here, step number 2, they have that simplify step. You have to do that. So 3/10 plus 5/10, yes, it's 8/10. But then we're going to divide by 2, which gives us actually 4/5 as our answer. Why is it doing that? Oh my gosh. Okay. All right. So wait a minute. Let me take these out so that I can show you this. Okay. I want you to pay attention to this helpful hint that I boxed, and it's in your book. To simplify a fraction, divide the numerator and the denominator by the greatest common factor. Remember, we did this where we said, so we have 8, 10, oh gosh. And then we factored them and we said 1 times 8, 2 times 4, right? These are all factors. 1 times 10, 2 times 5, and then they picked 2. Greatest common factor. Least common multiple is when you're doing when you're multiplying, okay? Simplest form, you're dividing. And I'm going to have a sip of this coffee while I'm talking to you guys. Okay, here we go. You know I need my coffee. All right, are we moving on? We're moving on. Okay. All right, so again, they did the same thing. This is just another part of the example. Now they are using models. I honestly would not make you get out models to do addition and subtraction. Now, the only reason that they're using the models is to make you understand how to simplify. Okay? So they're trying to explain to you that 4/5 is exactly the same size as 8/10. It's just, what do you notice about this? That the tenths are cut up into smaller pieces, right? The fifths are the bigger pieces. So what we have to do here is they just want you to understand that it's the same size. It's just smaller pieces. Okay? That's it. That's the equivalent part. I think that's really important for them. I like how they keep bringing that up in this lesson. When I thought this lesson was going to be, so easy. No, they're really bringing up equivalent fractions and simplifying. Okay, let's do our guided practice. Now, notice what they put in here. Write in simplest form. You have to write it in simplest form. You can't just leave it. Which, I will be honest, back in the old math books, the kids were allowed to just leave it and not write it in simplest form. Now, back in the old days when the dinosaurs roamed and I went to school, I always had to write my fractions in simplest form. Of course, I didn't know what that meant because I had the hardest time understanding fractions until someone explained it to me really, really well. So That's why I love fractions, because I had such a hard time with them when I was a kid that I love teaching them. I love teaching fractions. Like, I'm really upset that this chapter is when we're not in school, because I love fractions. I think they're the best because everyone thinks they're so hard, but they're really so easy. All right, so let's do it. 1/6 plus 2/6 is 3/6. And we know that 3/6 is equal to 1/2. So that would be in simplest form. Now, I want to cough, but I don't want to cough on you. Hold it. Sorry, I had to clear my throat. So, I know that 3/6 is equal to 1/2. The reason I know this is because 3 is half of 6. So I know that 4/8, 5/10 are all equal to 1/2, 6/12. Okay? 12/24. All right, 2 plus 2 is 4/5. Now, there's no number that goes into 4 and 5, so I can leave it alone. All right, boys and girls, I want you to go ahead. Oh. Describe 2 ways to decompose 4/5 into a sum. Okay, I would have done this in school. You could do, whoops. Oh, it's not gonna let me do it. All right, well, one way is 1 plus 3/5. Another way is 2/5 plus 2/5. Those are some other ways. Decompose means to take apart. Okay. Okay, here's your independent practice. Remember what they said here. Write it. Is it doing this? Write it in simplest form. Oh, I hate that. Okay. You can do. Let's see. What just happened there? Okay. Math of my world. All right. You can do independent practice up to, let's see. I'm like number 39. Do up to number 16. 2 to 16. Okay? And I'll put that in your instructions, so you don't have to worry about that. All right, boys and girls, remember, homework is optional. But, because everything you're doing is already at home. All right. Have a great day. I miss you. 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 I miss you.